Primarily, we're going to be talking about TIG welding, TIG, tungsten inert gas. TIG is used to be called a heliarc. That was a trade name, mostly done at that time on aluminum, other aluminum alloys. It uses the heat of an electric arc from a non-consumable electrode. All those big words, early in the morning. Let's back up just a minute and define welding. Welding is the joining of two similar materials by melting those similar materials and sometimes adding a similar material in as a filler. You can do it by fusion. You can actually heat two pieces of metal like a blacksmith does, lay them together, hammer them, and they will weld together. Wagon wheels were done that way for years and years and years. For a long time, that's the only thing they had. Then they came up with a way to create enough flame temperature by mixing a consumable or hydrocarbon gas, usually acetylene, adding in either air or more commonly pure oxygen, and get a flame that'll run, it'll get up to almost 6,000 degrees. You can sure melt steel with it. It's called gas welding usually, or oxyacetylene, that kind of thing. That's the way I learned. I'd never picked up a torch. I didn't know anything at all about welding until I started gunsmith school. But heliarc or TIG welding has allowed the gunsmith, especially, to do work that otherwise just absolutely impossible. It is composed of a power source to give us electricity, and it runs out on a cable to a torch. Now this torch has two cables to it. One is electric cable and one is a gas tube. And that gas is an inert gas, argon usually. I use either 100% argon or 98% argon and 2% CO2, whichever is cheaper at the time I'm buying it. I don't seem to see any difference in them. This gas, argon, flows from the torch around a tungsten electrode. I use 16th inch, 0.62 diameter, tungsten electrodes, 2% thoriated tungsten electrodes. They have a red tip on them, little red painted tip. The green ones are more for aluminum, stay away from them. Thoriated tungsten. Thorium is radioactive. It can hurt you. The Navy requires their welders to grind thoriated tungsten electrodes with a mask. I never have. Maybe that's why I glow in the dark. I don't know. The electrode is generally, always in steel, is sharpened. And there's two ways to sharpen anything. We'll call one a pencil sharpening, where you've got a straight angle that goes down to a point. The other is an ogive or a bullet sharpening, where you've got a long taper. We don't need a picture of that. I won't do it so I don't interrupt the video. But I generally use a long taper, just a long curving taper that comes down to a needle point. That needle point concentrates the arc. When you strike an arc, you get a little blue flame that's stabilized by the gas that's flowing around it. There's no oxygen allowed in there. It's got an envelope of gas all the way around it, and that sharp point concentrates that little blue arc in a small spot. That small spot melts your metal, and you feed a filler metal in with the other hand. It's a lot like gas welding. If you know how to oxyacetylene weld, TIG welding is a snap. It really is.
Thank you.
Oh, yeah, Mr. Snap. Yeah, snap is a joke. What we do in gunsmithing so many times is deal with unknown materials. We don't know what a Mauser bolt's made out of. I don't think Mauser did. Springfield's a mystery. Winchester, that's a bigger mystery. Car bumpers, rebar, old axles, all kind of stuff, badly melted together sometimes. What we're trying to do is to match the metal, the weld, with what we're going to fill it up with. We've got to match it because we're going to blue it. We may color case harden it. We may want to surface case it with caseinite or something like that. So we've got to have a matching metal. Probably the second hour we'll go into a lot of that, matching metals and that kind of thing. Just to give you an idea of how I learned how to TIG weld, I didn't know how to stick weld. That's a carbon, not carbon, but GMAW, I think they call it. It's some kind of weird deal, GMAW. Stick welding, arc welding, that's what they call it in the trade, where you're making trailer hitches, that sort of thing. I didn't know any of that kind of stuff. Early 80s, I was in need of a job, suddenly, and I went to Denver looking for a job as a machinist. Went to an engineering place called Castle Engineering. It was on Good Friday. Never forget this, about 2 o'clock in the afternoon on Good Friday before Easter. And the guy said we got 3 machinists at work here, but what I really need is somebody that can TIG weld because we make these steel tables for the machines we make. I said, I can do that. I'd never seen one. He told me to report to work on Monday. So I checked the yellow pages and struck off downtown Denver and found a welding school down there and bought a textbook. And over the weekend, I learned how to TIG weld, I thought, just by reading the book. I knew that the electrode stuck out from the front end of the cup about 3/8 of an inch or so, and I knew that to set the gas flow at about 12 pounds or so, or 12 cubic feet a minute, whatever, decifocals per fortnight, I forgot now what they're measured in. I know I set it about 10 or 12. I knew all of that, but I'd never seen one. So on Monday when I came into work, luckily he had a lathe job first, and then he had a mill job there for a day or so, and I kept looking over there in the corner, and there's this great big gray monster. All kind of dials. That thing had more dials and controls I had ever seen in my life. I was getting a little panicky. And I told the boss, I've never run one of those Lincoln Soft Start 400s before. I maybe ought to practice on that thing a little bit, make sure I know how that one works, like I knew any other one. So I sat down there and didn't make a total fool out of myself, but I waited till he had his back turned, and I learned how to TIG weld. I worked there for a year. Became a pretty good friend of mine. I told him years later that I had never seen a TIG welder when I showed up, and he said I fooled him. He said, what would you have done if you just made a big mess out of it and didn't know how? So I wouldn't have come back to work. But that's really the way I learned how to TIG weld, and it's the way I've learned how to weld on guns. Experiment. Try it. I go to gun shows. You've seen these big wooden boxes that the gunsmiths bring in. It's got all kind of junk in there. There's barrel bands and old military hardware. There's all kind of crap. Buy $5, $10 worth of that stuff. Buy a bunch of it. Start welding on it. Find out what works. Find out how to treat different things. Find out that something that's been forged, when you weld on something that's been forged, is a lot like welding on a snake's back. It's going to curl up and look at you. It's just go into corkscrews sometimes. Sometimes it doesn't. Figure out what needs what. We've got some enemies in welding, especially in gun welding. The main enemy is oxygen. Secondary enemy is carbon. And there's some lesser ones from that. Sulfur, silicon, aluminum, any of the carbides, bad news for a weld. Preparation, very, very important. Now let's look at the first enemy of welding first, oxygen. What is bluing? It is oxidized steel. So if you don't take the bluing off before you weld on something, you are adding oxygen into that puddle, and you're going to have pits. Just about every time. Secondary enemy, carbon. Gun parts are usually hard. How does steel get hard? Carbon. Case hardening especially. When you have a case hardened part, like a Mauser bolt, there's a skin 30 to 40 thousandths deep that has got a lot of carbon in it, a bunch. And when you stick the arc to it, it starts boiling. You can just see that stuff kind of foaming in there, boiling out. There's a way to kill that. In order to kill carbon, we need to anneal the steel. Everybody know the term annealing? Annealing is just making the hard steel soft. I do it in an ammo can full of lime, just regular old lime. You go to the hardware store and you buy a 50-pound sack of the stuff for $3. Type S, I think they call it. I fill a ammo can about 3/4 of a full of this lime. You heat up a piece of metal to its temperature of transformation, I think they call that. Most of the old gunsmith books calls it cherry red. I have never in my life seen a cherry that color. Maraschino comes close. Here's an easy way to do it. When steel gets to its temperature of transformation, it becomes non-magnetic. Pick up a handful of these magnets that stick on refrigerators, stick that on a Mauser bolt, heat that sucker up till the magnet falls off. Put it in the lime, hit the side of the can a time or two to pack the lime around it, and go get a cup of coffee. It's going to take an hour for that thing to cool down. When it cools down, it's going to be good and soft. And that carbon will not give you any trouble. You can also cut the bolt knob off with a hacksaw instead of having to use a friction saw. There's little tips and tricks, hints. How many in here already TIG weld? Okay. I don't see Steve Heilman anywhere. I was going to say that I'd feel like a house painter giving a ceiling seminar to Rembrandt. Judge.
Mike, what's the minimum size TIG welder you would recommend buying if you don't have one now?
Okay, material, yeah, TIG welder, that's a good question. Assuming that a gun maker only welds steel and stainless steel, no aluminum, you can do with 150 amps with no problem at all. 150 amps, you do not need a water-cooled torch. Do not need it. Air-cooled torch is just fine. They don't get that hot and you're not going to be doing that much. If you're welding together aluminum framework for ships, airplanes, whatever, you need a bigger TIG welder. You're going to need 220 to 250 amp and water-cooled torches and filters and all kind of crap. But for gun welding, a small one is just fine. Trying to think of the company that's making a real nice little Econo TIG. Miller Econo TIG. I used that on a job down in Elko, Nevada at a gold mine one time to do some pipe work, and that was a really nice little machine. The important thing on any TIG welder is to have a variable amperage control. You just about have to have it. I use a foot pedal. I've also got a thumb wheel hooked up to a torch, and I'm trying to use that a little more, but the foot pedal is just so easy for me, it's hard to change.
Jack,
Yes.
point out that on the water cooled, all it does is cool the cable,
Yeah.
and if you got a water cooled, you can use a much lighter cable, much easier to handle than you can if it's not water cooled.
You can use a lighter.
The water is simply to keep the cable from burning up on you.
Yeah.
So with the water, you use a much smaller cable. You know, going up
Ah,
your head.
okay. Ted Blackburn brought up the point that if you use a water-cooled torch, you can do with a smaller cable, more flexible cable. I've never used a water-cooled torch. I really don't know. In fact, I priced them one time, and that kind of, I'll probably never use one.
It's got a lot of bucks.
Yeah.
Oh, yeah.
But a water-cooled torch, the water jacket wraps around the power cable and keeps it cool, so you can use a smaller gauge wire for the same amount of power. But on a 150 amp arc welder, you really don't need it. You can feel the cable, it'll get hot. Sometime doing a bolt knob, the torch will get a little warm, but it's not bad. Some safety concerns. TIG welding is much brighter than other welding. I use a number 10 filter I've never used one of the instant darkening filters, but I understand they work really well. But a number 10 is just about right. Be sure to protect any exposed skin. If you want to hurt, weld on a bolt knob in a t-shirt. Arc burn never tans. It just burns and then it falls off. And then it burns again and it falls off. And about the third layer, about the 3 bolt handles in one day, and you're going to lay around with baking soda all over you because it will burn you. It is very, very dangerous from reflected light. This same engineering company I was talking about had an apprentice. We call him Kenobi for some reason. And he was helping hold some pieces while I learned how to TIG weld on a table. It would probably cost him $3,000. Neat working on somebody else's stuff. But when I would say arcing, you know, and flip the helmet down, and he would look off in the corner of the room somewhere. He'd just look somewhere else instead of closing his eyes. He got terrible arc burns from the reflection of the arc against sheetrock. Terrible arc burns in his eyes. He was off work for several days. Maybe it wasn't that bad, but he took off several days. It's the other thing, of course, is remember what you welded on and don't inspect it too fast. That's another safety concern. As far as heat transfer to the rest of a part, it's amazing what you can do with a TIG welder if you're just careful. I'm going to pass around a bolt. Just start it here. Some of you might have seen the short action 700 rifle that I had on the table. This is the bolt from it. 700 Remingtons have a silver soldered on bolt handle. They melt off of there at 1110 degrees or so, or sometimes fall off when you least expect them. I cut that handle just about halfway between the body of the bolt and the knob and welded on another bolt knob with a TIG. And I had a heat sink in the back of the bolt. It's a 1/2 inch 13 thread on a Remington, so you can just get a copper 1/2 inch 13. You can buy them at electrical stores. Screw that dude in there. Copper is a very good heat transfer material, a lot of thermal transfer, and it will suck a lot of that heat away from it. I didn't use heat stop or paste or any of that kind of stuff. I just hit it with a TIG torch, weld a little bead, wait just till it quit turning red, dunk it in the water. Make sure it's dry, stick it up there and weld another one. Just kept on welding. Welded it right on, no problem at all. It's common to weld on a Mauser handle and pick the Mauser bolt up by the lugs and walk over. I've got a coffee can about 3/4 full of water, and I just hang the side of the handle on the side of the can and suspend the lug end down in the water, and they're not hot. They're not hot on the lugs. If you have problems with it, take a piece of copper, 2 pieces of copper, put them together, bore you a 703 hole in the middle, and then clamp the bolt between the 2 pieces of copper. And then you have no heat transfer to the bottom of the bolt at all. Any questions so far? Anybody just speak up if you got a question.
How about eye protection, Jack?
Eye protection, number 10 filter in a hood. Yeah, it's
I recently got one with a great big opening because of the glasses.
yeah.
Just a little one, it's hard to get focused on it. That big one sure helps a lot. Anyway, especially with glasses.
I've got one. Ted was talking about you can buy welding helmets with the big picture window filters or the small narrow filters. I'm still using a narrow even though I've got a big one because they make magnifiers to go in a small one. So I use a magnifier in the small one, and now I'm using reading glasses under that. Boy, it's getting old, it's tough. Maybe it does beat the alternative though. Yeah, anybody's got a question, just speak right up. The TIG welding, yes, Dave.
Back a minute ago, you read test green tip. What happens if you happen to screw up and lose the color on that and use a green in place of red?
I don't know. I've never tried that. Aluminum welding uses a totally different, different power setting, different power everything, and you use a ball tip instead of a sharp tip. You ball the end of on a piece of scrap.
Another question I
Yeah.
have on your variable length, you're talking about not so much setting the full length for whatever reason, but the start up and close down.
I've got an old Hobart HF 250, high frequency 250, maximum 250 amps. On TIG welding you use DC straight polarity. That's what's used in, for steel and stainless steel. You're using alternating current with aluminum, but we're not even going to talk about aluminum except in how to prevent something else. 150 amps is the maximum you get when the foot pedal is all the way down. When you stomp on the accelerator, you got 150 amps coming out of the tip of that torch. That will immediately weld, it'll melt out a puddle. This is a hot son of a gun, really hot. As soon as the puddle starts, then you back off on the power. As your part heats up, you'll use less and less power. You've got to add less and less heat to it. When you're welding on a little bitty part, it's almost instantly hot. And unless you have a way to back off on that power, oh, it's just embarrassing when you see that big sparkle hit the floor and just scatter in 19 different directions. That was the edge I was looking for. And now it's gone. Tough deal.
Your welder use a high frequency start or just strike start?
I do have high frequency start, and that's really handy. What that means is the electrode does not have to touch the material to start an arc. When you push on the switch to turn everything on and start up everything, there's a high frequency current that runs between the tip and the part and actually starts an arc where you can see what you're doing. That is very, very handy. There's another way to do it, and I'm going to draw on this a little bit. The TIG torch has a cup. It's a ceramic, they're usually pink, a ceramic cup. The electrode sticks out of the center of that about 3/8 of an inch. You can actually vary that a little bit, but about 3/8 of an inch is common. If you're working on a piece of flat material and you want to weld right here, put the edge of the cup down with your hood up. Sit there and position that thing. Get your electrode right over that pit that you want to work on. Then flip the hood down, start the arc. Now it may be too close. When you start the arc, then you'll have to pull it back, but at least you can see what you're doing. That little arc is just like a spotlight. A number 10 filter is about darker than 3 feet inside a cow. But your arc will come out, it'll be just about that color or just about that shape off of the tip, and you'll be melting out a puddle right there.
Jack,
Yes.
what is the angle of attack, or what is your guesstimate of what your angle of attack is?
Just about there, 30 degrees off of vertical. Just about 30. That's probably closer to 40, but just about 30 degrees. And you can actually alter that. If you're welding up a hole, it's 90 degrees. 90 degrees. But generally, I'm right-handed, so I start from the right and try to come toward me. That way your filler rod, I come in at an angle. If the torch is coming this way on your material, the rod is coming in just about like that to fill in the puddle. And looking at it from ahead or above, if the torch is at this angle, the filler rod comes in at that angle. That way you get vision. Seeing what you're doing is always a problem. It really helps if you remember to wash the filter before you start. The filter gets smoky, it gets splatter on it, it gets messed up, and when you strike that arc, it forms kind of a halo. You see an overall brightness with a bright spot in the middle. If you'll wash that filter real good, I use dishwashing detergent and water. Wash that filter good, keep it clean, you'll see much, much better. You may experiment with a little bit lighter, a number 9. I wouldn't go to a number 8 filter. 9 I think is, I'm not sure what industry standards are, but 10 I know is safe. Yes?
Miller gives the 12 if you're using the automatic darkening help.
A 12?
In their school, that's what they suggested to use when you use the automatic darkening help.
Most of the time, the outfits that sell TIG welders assume you're going to weld aluminum, and that does take 2 steps darker. So that could be the difference between a 10 and a 12 that's supplied. Aluminum is very, very bright. And if you start messing around with magnesium, Lord help you. Bad stuff. Yes?
On that high frequency,
Yeah.
I've had occasion to hook up stingers, using a rod. And you're doing that with high frequency, you don't have to start an arc with the rod, which sometimes that's trouble with it. Sticks all the time. You gotta use
7018 especially.
And I'd like to ask what he thinks about those self-darkening.
Yeah, who in here is using a self-darkening? All right, there's a lot of folks around here got $125.
They've gotten the price down to a reasonable price now. $120 or $30.
They're what?
$120 or $30 as opposed to the $350 they started out at.
Ah, well, that's handy. I may have to have one of those. Yes, JR. That's what I've heard. That's what I've heard. I just can't see how it does it that fast. It's like them thermos bottles, you know. Like the thermos bottles, keep hot things hot and cold things cold. Little boy said, I got 3 cups of coffee and a popsicle in mine. Yes.
One of the other things to your lens is you can actually put like packing tape on it and peel it off every few hours of working.
Yeah.
Get a fresh, clean surface
Yeah, tear off.
to protect your filter, which is your expense.
What happens when you got a splatter on it and it melts the thing in front of your eyes?
Well, that's what that protective layer in front of your filter.
Oh,
is, that plastic protective
Yeah.
layer built in too.
All right, yes.
I was taught Jack when you sharpen the tungsten, and how much difference it makes or not, I don't know. When you sharpen it on a wheel, I was taught to keep it, when you sharpen it with a wheel here, that you kept the grain marks on the axis with the tungsten, which allowed the gas.
That's a good point. I'll repeat the comment. When you're sharpening the tungsten electrode, to give you some scale, this is 0.62, 1/16 of an inch. When you sharpen that electrode, keep the grind lines in a vertical plane this way. Point up and then roll it on the wheel. And what that does is a free flow of electrons, or some other technical explanation of how electricity acts on that axis. I've noticed the same thing. I have ground them sideways and you get more dispersion on the puddle. What causes the most dispersion on the puddle is dipping the tip of the electrode in the puddle. That immediately sticks a big gob on the end of that electrode and you get a bloom. It's like a big flower of arc that comes out of there. You lose the focus. It's normal to get some dusty looking deposit, little speckles and deposits on that electrode. That's normal. But when you got a big gob on there, usually it looks like this. It look a lot like that with a little bit of a tip on the end of it. And instead of your arc coming off this way, it'll come off that way. And you lose your concentrated heat. Yes?
One thing about the visors on the helmets, we're bifocals. A narrow visor is going to be problems.
Yeah.
I can't use a narrow visor because it's just between my bifocals and head, I can't see.
Seeing vision is the biggest problem I think most people have with any welding. It really is. And TIG welding is no different. And when you're shortening an action and you got pits in the left raceway, that's really tough. That's really tough. Talk just a little bit about how we're going to protect this puddle away from the air. Now we know that out of this cup we have a flow of argon coming out of there that shields and pushes away the atmosphere away from our puddle. If you get too high, if you lift the cup way up here and have to use too much power, you've got too much turbulence. The turbulence of the gas coming out will actually suck oxygen in from the sides. The same things happen if you have too much pressure on the gas. You want just a soft sigh against your cheek. That's really exciting when you're putting that torch up next to your ear and you're wondering if that son of a gun's going to go off. But you just want a soft sigh. But the problem we have in the summertime especially, you open a door, little breeze come through, all of a sudden you get this cauldron, sparks flying everywhere. What in the devil happened there? A little zephyr came through, pushed away the argon, exposed that puddle to oxygen. Oxygen intensified the already melted metal, got it above its burning temperature and caused the sparks. That's where they came from. The other problem we have is trying to weld in a place where the gas can't get to. Inside of an action rail is a great example of that. You're welding up a Mauser and you've got the inside rail, something like this, and you've cut this thing in half and weld it together from the outside, hopefully, weld it all the way around, and then you got some pits and some voids left inside. You got to make a decision. Do I get out the hacksaw and start over, or am I going to try to fix it? Take your pick. I generally I check to see if the action is good and straight. If that son of a gun welded straight, I'm going to spend a lot of time trying to fill up that void in there without having to cut it back apart. Because when you weld them together and they come out straight, you say, oh, praise be, how did I ever do that? Then you find the pits. Here's a way around it. Weld in a box. Argon is heavier than air. You can take I got like a half of a 20 millimeter ammo can, one of the big ones, and I sawed the thing in half all the way around, so it's just about that deep. In the bottom of it, I've got a drill press vise. I drilled and tapped the side of the drill press vise and put a copper strap on it that hangs outside the box. I clip the ground clamp on, hold the part in the drill press vise. Then I got all kind of scrap iron in the bottom of that box that I can prop that vise in just about any way I want to. I can set it around, I can get all kind of angles. And then I'll hit the foot pedal, which on my machine starts a solenoid, which starts the gas flowing. Just hold the torch over the box, hit the foot pedal, not to start the arc, but to start the gas. Let the gas flow in there until you strike a kitchen match, and when you dip it in the box, it goes out. You know that that's no longer atmosphere in there if a match doesn't burn. Works great. Then you try to get around that box down in here and try to weld in the backside of an action that you can't reach, but you can run the electrode way out. You can run that electrode out an inch if it's in an inert atmosphere, and it'll still work. You will have trouble if you're trying to weld this way. It'll arc there. It's going to arc to the closest point. So it's still a whole lot of contortion movement. I had threatened several different times of trying to make a kind of a right angle electrode and all kind of weird stuff. So far I hadn't done it. I'll experiment on that later. But welding in a box is really handy on parts where you have to stick the electrode way out. It really works. Yes?
Yeah, I just wanted to mention a little tip that Pete Grissom gave me a couple years back. He uses something called a gas lens on his torch. And what it is it's got screen wire inside to diffuse the gas,
Yeah.
reduce the velocity, and eliminate the turbulence as the gas is coming out of your torch.
That's a good idea.
Yeah, your box idea is fantastic, but when you're welding outside of the box, it makes a big difference.
Aha.
You could buy them.
Good idea. Diffusion screens for the inside of the cup. to diffuse the gas when it comes out of there. It actually makes a laminar flow, a screen does. You've got parallel turbulence trails like a wind tunnel. Anybody else? Yes.
You might caution them to be sure that whatever they're welding is grounded good.
It's very exciting when your filler rod hits the tip. that can get excited, especially with wet tennis shoes or something. When you just kind of accidentally hit a filler rod to the tip and bzzz, make you hum. Any other questions on that? I'm going to assume right now that we're going to be welding on steel, rifle steel, carbon steel, chrome moly steel, whatever. I've already cautioned about the blue. Most of us use naval jelly or Brownell's blue remover to take blue off of something. That's phosphoric acid. Phosphoric and hydrochloric about equal parts. Phosphoric acid has phosphorus in it, and phosphorus is another contaminant. It's not as bad as oxygen, not as bad as carbon, not as bad as sulfur, but it is a contaminant, and phosphorus will weaken steel, and sometimes it'll cause a pit. I prefer to use tungsten carbide burrs on a handy grinder. I use a front exhaust air grinder to blow those cotton-picking little sharp chips away from me. I want them to go to the other side of the shop instead of down my collar. But just a little ball burr, tungsten carbide, never use aluminum oxide, never use silica carbide, never use a stone on a burr to grind out where you're going to weld. Always use something that's not going to leave a residual. A aluminum oxide wheel, a little red wheel on a Dremel tool, that sort of thing, will leave a piece of that aluminum oxide grit in there, and when the arc hits it, you'll see it. It'll be a little miniature volcano. Tungsten carbide, you don't have that trouble. You just got to fight off those cotton-picking little sharp razors. Any question on that? In any welding, the integrity of the weld depends on how well the filler metal penetrates. We always start out with a V if we possibly can, and they call it a J groove or a V. Just assuming for a minute we're going to weld on a Mauser 98 bolt handle. And they come to you looking a lot like that. This is a little bit above center. I cut them off. There's two different ways to weld them, of course, the pre-war Winchester way and the Mauser way. The Mauser way leaves about 1/8 of an inch here, 80 to 100 thousandths, somewhere in that area. I cut it off at an angle. I leave about 3/8 of an inch out here. I want the cocking cam, the extractor cam intact. I want to leave that there because that is a kind of a primary specific angle that is best left alone. So about 3/8 and 1/8. Cut it off. If you anneal it first, you can cut it off with a hacksaw. Sometime you can get them off with a hacksaw if you don't mind tearing up a $3 blade. Then the new handle will come in at an angle this way. This area in here is all going to be welded up, every bit of it. The primary important first thing to remember is the first pass. That one right there, right through the corner. I set them up to where they're actually got about 25 to 30 thousandths gap between the two. I never let them touch. And when I go through there with the first pass, it's going to be hot and fast, but it's going to go all the way through. I want weld metal hanging out the bottom. Once you get that, then the rest of it is just fill-in work, and there's a bunch of it. With a TIG welder, and I looked all over the house for it and I couldn't find it, but one time I built up a little stick man that was riding a horse on a piece of steel base plate just by building it up with a TIG. Just stacking it up like you used to sand castles, remember that, dribbling the sand in the water? Same thing with the TIG welder. You can just build anything you want to. You can go out to the side, you can do all kind of weird stuff. That's when the boss is not looking and it's somebody else's machine and filler rod. Normally speaking, I try to fill in looking straight down on what we're going to weld up. Handle comes in something like this. I come in and weld crossways for several times on both sides, bolt handle and the bolt root, and then I'll switch to this way, where you're coming in this way. The first one's cross and then lengthwise, and I leave both ends, the front and the back, to last. And I usually even let the handle cool. I'll just take a break. I'll hang it on the coffee can so the heat doesn't crawl down to the lugs. And I'll take a break somewhere and wire brush the whole joint. Just really shine it up. And get in there with a scribe and see if there's any kind of little crusty stuff. Sometimes you find silica that comes out of the steel, and it'll be like sand. Dig that stuff out of there. Use your carbide tool. Grind that stuff out of there. Then set the bolt up, usually vertical, and weld up the back. This area in here, weld that up, turn it over, do the same to the front, even everything out. The corners, I build corners way out. I want plenty of metal there. Then rough grind it. I scare the daylights out of customers sometimes welding on bolt knobs, because my primary tool to rough them out is a half round rasp about that long. It's a second cut half round that I bought at a surplus store years and years ago. And you can get on that thing, and I mean, you can shuck the steel right out of there. Look for pits. Look for pits. You will never find all of them until the 600 grit finish. That's where the last one always comes out. I'm a firm believer that in some places in the universe there is a pit, and sometimes there's a gun around it. And sometimes they won't leave. You can't drive that sucker out of there, but I always try. When you find a pit, get the carbide burr and grind it out until you no longer see any of it. They tend to be hooked together like with little spider webs. There'll be 3 pits hooked together with a little stringer. You can grind out a big pit, and all you see is just a very, very small dot. So it's okay, I'll weld that in. And you see this thing kind of bubble and boil and stuff, and you shape it back down, and where you had 1 pit, now you got 3. So you grind out those 3, and you weld. You see that little bit of a bubble, that's no big deal. You weld that sucker back up and build up a little bit of extra metal there, grind it back down, and now you got 5. If you don't get all of the pit out, it will come back. Here's another tip. You cannot enclose an area by welding. Hollow bolt knobs, I don't have one with me, but some of you have seen the things. A bolt knob is actually hollowed out where there's only a skin around it about 40 thousandths thick. You can't weld up that bolt knob all the way around without having a hole in it somewhere. If you try it, right at the last minute, a little volcano come out there and blow a hole. It's got to have room to breathe. So anytime you try to weld up a square bridge on a Mauser, real square bridge, drill a hole in the top of it. Weld it all the way around, then cover up the hole at the last minute. Otherwise, you're going to have pits every time. Any questions so far? I'm just skipping around.
Drilling the hole on that?
What's
You're talking about drilling the hole, it's kind of like a square bridge?
in the top of the square bridge? Yeah. There's generally a locator hole or something that holds a square bridge where you want it anyhow, and that'll serve. I generally just drill a 1/16 inch hole in the top of the bridge and the new part and stick them together so it doesn't slide around. Really embarrassing to weld on a whole square bridge and find out it's off to one side.
Jack?
Yes.
Get that, trying to enclose something with the weld and
Yeah.
not blow out. Don't you find that also applies to when you're filling in, you want to be sure you're filling all the way to the bottom and out?
Exactly. We're going to cover that.
Metal has a little one down deep in it, it's going to just keep going to the surface.
That's right. Pits will always come out, and they'll always show up at the most inopportune time at the worst place possible. Ted brought up a good thing about welding holes, and all of us do that. I'm going to pass around a double heat treat Springfield. Somebody put a set of stith mounts on this thing years and years ago. The stith mounts come in at an angle on both bridges. I got that action really cheap not too terribly long ago. And what I do with those, I generally use an 82-degree countersink. Just get in on that hole and countersink it out. There's the surface of the metal. I try to get down here to where there's only about 2 threads left. Just really take out a big piece. Now, I didn't take out too much on the front ring because I didn't want to have to do too much re-lettering. Have to recut the stamping there with a graver. But when you're welding up holes, make sure that you've got plenty of room. Get a big funnel shape. I use 82-degree countersinks, and make sure that the bluing is removed from around it. Just hit it with a file, or I don't like to use paper. You don't want to use aluminum oxide, you know, polishing paper, that kind of stuff. I use a file. But when you start welding a hole, any more questions on the bolt handle?
One question.
Yes, sir.
Do you ever weld directly into the bolt body on the bottom? Where you leave that 1/8? Do you ever go in and weld right to the bolt body?
The question from Jerry Fisher is, do you ever come in here and weld to the bolt body to make it like a pre-war Model 70? Pre-war Model 70 comes in much further down on the base. Yes, I do. I sure do. And they will sometimes warp. I made a tap for that buttress thread, the Mauser buttress thread. Just turn it out of 01, heat treat it, hardened woodpecker lips, and cut some reliefs in it. You can run it back in there to even it back up. We'll cover, probably the second hour, we'll cover a little bit of heat treating and reheat treating the cocking cam on Mauser bolts. That's very important. Yes?
On the bolt handle welded on, I had somebody weld it on for me, but to me I cut it square off instead of on an angle.
Yeah.
And then I just put a 45-degree chamfer all the way around it.
Yeah.
Same with the bolt handle, match together, just weld it around it.
You can certainly do that. The comment was another way to set this up instead of the V's.
I believe that's all that filler.
Yeah, you're talking about cutting the handle off short.
Well, what the 3/8 is, cut out 3/8. I mean, you are.
Here? Okay. Yeah, you could do that with a with an Orbador style.
Okay, here, put a chamfer all the way on all
Yeah.
sides, and the bolt handle comes down here. Oh,
I hope that's not a dangerous game gun.
a what?
A dangerous game gun.
Then weld it on all 4 sides.
It's likely to fall off. Yeah. You can do this, but it's very weak. You have, looking in cross section, you only have that much filler all the way around, or more, depending on how you sharpen that. But what you've got here is an area that has nothing. And I'd rather have solid steel.
Well, that blowhole effect comes in.
The blowhole effect comes in there for sure. You're going to have a pit somewhere. You can pick where it is, but there's going to be a pit, and it's going to be a big one. Any other questions on that? Welding up holes. We will cover welding up holes in pre-64 Model 70 side rails for those miserable side mounts that were so popular years ago. We will cover that. Assuming somebody has, some hammer mechanic has drilled a hole off center, or even better, off center, then fill it with another screw and then try to drill it off center again. You know, and you can get 4 or 5 of them there. They look like a little flower or something. It's got all kind of weird stuff in them. Counterbore the thing out. Get you plenty of room to work, big funnel. Go in with the electrode as close as you can get down here to the bottom, and you want to weld right around the bottom. right around here. Just start and looking straight down on it. Start in on one side here and weld around, and then just start coming up. Add a little heat to it, add more filler rod to it, and just come right straight on out until you have a bubble of extra metal up on top. Now the one problem that most everybody has, and I do too, is with undercutting. Where on the edge here you've got an erosion around the edge. Just a little bit of a dip there. That's caused by too much heat. That's all that is. You got too much heat, there's too much arc that comes out here and blows away a little bit of metal. If you'll just cool down, you can do that. With a foot pedal, you'll have to learn how to do this. It's a touch kind of a thing. You start hot, you back off on the heat, you keep on backing off on the heat as the heat in the part builds, and you're adding filler rod. There's two ways to cool that puddle. One is by backing off on the heat, and one is by adding more rod. You adding in more filler rod, that's cooling that puddle. So right at the last, you're about half throttle, and you're really feeding the rod to it to cool that thing down. And that does away with undercut. You notice on that spring field, there's a little bit of a difference in color. I put some cold blue on it and steel wool it several times and messed around and trying to get it where you could see where the hole used to be. Normally you won't see that when it's finished, hopefully. Difference in color is caused by the difference in hardness or the difference in alloy. That's what it's caused by. The hardness we can take care of by annealing, but that's bad to do on a front receiver ring because we don't want to anneal it. People ask me, how much welding can you do on a front receiver ring? As little as humanly possible. If you've got a few pits below the wood line on the Mauser action, don't try to fill them up. All you're going to do is warp something. Warpage is a tough deal.
Jack,
Yes?
I never had any luck welding holes for that reason. You get them glued and there's two colors black on them. And, so I always plug the holes with
Similar metal?
Well, I hit an early 71 Winchester with the, changed the tang length, which was the first ones were longer.
Yeah,
Anyway,
right.
it was just a 2-digit serial number.
Yeah.
And it had 6 holes in the left side. And luckily I had a blown up 71 Winchester there, and I opened the holes up with a taper pin reamer and drove pins in there that I turned up on the lathe. And now they're exactly the same kind of steel. When I got that thing done and re-glued in the original method, I took it to a very good Winchester collector, he declared it original.
Yeah.
And then I told him,
With Winchesters, the best thing you can possibly do on holes is to ream them out with a tapered pin reamer and then get similar metal from another Winchester. Anytime you find a blown up Winchester, snag that action. You need that metal.
and one other thing, when you turn the pins, you should have a little more taper on the pins than the hole has.
Yeah,
So they tighten up on the outside.
right.
On the 71, you could look inside on the rails where the bolt. And there's 2 places where there's little.
Yeah, little half
It
moons.
looked like an end mill mark. Only I knew what they
Yeah.
were. But those are on the inside, and
See, I use a Graver Max with a rounded punch to peen the insides. I put the outside on an anvil after it's driven in there, put the outside of the action on an anvil, and then get in there with the heavy piece, hand piece on a Graver Master and our Graver Max and peen the inside so it covers those up. Most of the time when you hear somebody cuss TIG welding, they're trying to do it on a Winchester. Not to badmouth Winchesters, they just didn't use very good metal. Where's Gary? He's back there. Yeah, I sold you a shortened pre-64 Model 70. Whew, man, what a miserable thing to weld.
Lyle Feely's got that.
Yeah, very good. Well, that was a tough job. Pete?
On the, trying to re-black those things, if you have an area where the heat treat isn't super critical, you can heat it up to about a dull red, about 800 degrees.
Right.
And let it cool real slow.
Yeah, annealing it.
The halo. You still have some problems if you're rust pulling. What you want to do is
Yeah.
And they'll rust unevenly. The weaker the solution, the better, and that'll help. But I think plugging it is probably the best way to go.
Good tip. Everybody hear Pete? On the, I call that curing the bullseyes. We're going to cover that a little more in depth. Any more questions? Welding up holes on a front receiver ring like that Springfield right there, not too much trouble. I use a copper heat sink that's threaded like a barrel shank that goes in, that just gives more mass to the inside. You don't have as much warpage, that sort of thing. I've got a whole selection of all kind of different heat sinks that I use, usually copper. We're going to cover something just a little more complicated here. Sharp edges. Sharp edges are the most miserable thing to try to fix ever. I guess it was DWM that when they indexed the non-locking screw 1909 Argentine guards, did it with a chipping hammer, it looks like. Yeah, and put that great big peck mark right on the side of the tang screw holes. Great big thing. And oh man, they're tough. They really are. First off, they're full of dirt down in the bottom. You got to clean them out. I do it with a burr. Here's a good secret. On DC straight polarity, which is how we weld with a TIG on steel and stainless steel, that puddle will not stick to aluminum. So if you've got a pit on the side of a sharp edge, use an aluminum plug inside the hole. Just make a tang screw head out of a piece of aluminum and weld it. You can go right over it if you want to, then take the aluminum out. It won't be sticking. And you can go right up to the edge. Same thing like on lock plates. Oh, miserable. Nothing quite as bad as having a fine old gun, nicely engraved, that got dumped in the Zambezi somewhere, and always got a draft on the back side of the lock, on the lock plate, of course, and it's eaten away, got pits of some kind, and you've got little scattered pits, or maybe somebody dropped it on the floor, hopefully not you. By mere physics, steel has a lot of surface tension. That's why when you weld a puddle, it will build way up without flowing out. Everybody's seen a drop of water on a sheet of glass. That's surface tension that makes that drop of water stand up there. We want to try to break that surface tension. With a drop of water, you can just add a dip of toothpick somewhere in the soap, any kind of surfactant, stick it on the drop of water, and all of a sudden it just flows right out. Soap makes it less so. I've never found anything that will do that with steel, and that causes a problem. When you melt out that corner, trying to fill in a void here, you can make a puddle, but you've always got a void on each side of it. When you weld in here, it's gonna melt away that corner. And the only way to get away from that is to have a plate that butts up against it. You got a lock plate and you've got a big ding here, cut a piece of aluminum that fits that lock plate. And then you can weld right over the top of it, and you can actually kind of blend that in, weld up too high, weld up a big bubble, and then just use the torch to move that bubble around and keep the flame over on the bubble and push it toward that void. And as long as you've got an aluminum plate wrapped around it, you can actually push that metal around and fill that void up. It is a terrible job and never guarantee success. Never. A lot of those English lock plates are forged and they will curl. And then you got a problem. Pete, have you found a good way to do those? Damn.
Discretion being the better part of valor. Don't try it.
Jerry's got a good idea. Don't screw with it.
What keeps the aluminum from not melting? I mean,
It melts at a higher temperature than the steel.
it does still.
Yeah, sure does. And it gets real hot too. Don't rest your arm on it. Woo-wee. That's exciting. Complicated jobs. The most complicated job that I tackled was for Hamilton Bowen, who's a member here. And it was on Ross Seiferd's first 475 line ball. He wanted to put 2-leaf express sights on it. He asked me if I could do it. Being young, dumb, and foolish, I said, of course I can do it. I don't know if you'll like it, but I can sure do it. Well, I experimented on his gun and it came out pretty good. So I decided to do one for myself. I'm going to pass it around without the cylinder just so you can hold on to it. I hate people that do this. I get nervous. Grab it. That's my personal 41 mag I finished in 1989, which was, I think, a year after I did Ross's guns. I did 2 for him. That's a Ruger frame that the rear sight notches and grooves, the big slots in the top that was cast in was removed, or it was filled in with weld. That's a pretty good indication of if you use the right rod, you don't have a color change in chrome moly steel. We'll cover rod here in a few minutes. That gun has actually been welded on in 3 different places that you can see from outside. First, the rear, what do you call it, top strap. The Ruger sight slot, it looks like it's done with probably the mold was done with a big saw cutter. And I filled all of that in, every bit of it, plus it's got a notch back here, that was all filled in. Also, the grip frame has been shortened by 5/16 of an inch. It's a Super Black Hawk grip frame, and I like my little finger underneath. I got big hands, and that's just the way I shoot a single action. I shoot that one every day. So I shortened the grip frame by 5/16 of an inch. Everybody about ready for a break? Let's take we okay with the film? Let's take a 5-minute break or so and then gather back. People ask me how tough rust blue is. That's some gun's been in that holster since 1989.
Oh, man.
And I wear it.
Looked like it was done yesterday.
I know it. I go down the river every afternoon and shoot carp. Yeah. I got a little bit of wear on one side of the muzzle. That's it.
No, well, that's done right.
Yeah. I let that sit too damn long. I got tired of waiting on it, so I went home and went to bed. I got back, and boy, Bob Snap just reminded me if anyone is going to put a tapered hole in the side of a Winchester and drive a plug in, to make sure you got an anvil on the back side so you don't cave it in. There's a gunsmith lived up in Wyoming one time, kind of by himself, and he got kind of lonely and took a trip down to Denver wanting a pet. He figured he'd buy him something, but he was a gunsmith, a little strange. So he figured he'd get something a little unusual. He went to a pet store and the guy tried to sell him a snake. He said, I ain't about to spend no night with no snake. That's all there is to it. He said, well, how about this cat? He said, I hate cats, targets. The fellow said, how about a bird? And the gunsmith said, that may be pretty good. You got a bird? He said, yeah. I got a Paraguayan parabolic purple-billed parrot back here. They're beautiful birds. You'll love them. Great big parabolic purple bill on this Paraguayan parrot. The gunsmith said, man, I like him. How much is it? He said, $5,000. He said, man, I told you I was a gunsmith. I'm not an oil man. I need something a little cheaper. Pet store guy said, well, I got one back here that is not perfect. He's got a wart on his nose, on that parabolic purple bill. So he's got a big wart right up on the top of it. And so we can't sell him the way he is. And the guy says, shoot, I'm a gunsmith. So I'll set him up and draw file that thing down and polish it off a little bit. I believe if you just touch him once to the buffer, you'd never tell that wart was there. Pet store man said, you can't do that. It says big wide nerve that goes right down the middle of that parabolic purple bill, and said, if you touch that nerve, he'll die. Fellow said, I'm a gunsmith. I can draw file to 1,000th. I can polish to 1/10. He said, there's no problem whatsoever. I can do it. So he sold him the bird for $100. Next week, gunsmith was back at the pet store. Said, you got another one of them birds? That guy said, I told you, you went too deep and killed that bird, didn't you? He said, no, I just set him up for the job and squashed his head in the vise. Wonderful Chesters, are tough to deal with, and there's so many nice old pre-war Model 70s. It's got a multitude of holes down the left rail for a multitude of side mounts, and none of them really work all that well, it seemed like. Every time they'd not work right, they just add a couple more holes. Some of these guns are well worth restoring if we possibly can. We got a problem. There's enough material there to weld on. There's enough material to drive a plug into. There's enough material to do a lot of things, but Winchester was unkind when they picked the alloy. I think they probably went to Nucor Steel and said, you got any leftover rebar in 1.5 inches? Because when you get inside of a Winchester Model 70, you're going to find leaves and asphalt and all kind of stuff. I mean, it just looks like they're just full of trash. And you start welding on them, and you may hit something that just erupts into a big geyser of foam. I call it bright foam. Usually it's carbon or manganese stringers in the forgings, and they're just miserable. They've also got a lot of nickel in them. Now, nickel is an alloying agent in steel that does several things, but primarily to the gunmaker, what nickel steel does is allow them to air quench an action. It slows down the action of hardening in the quench. If you've got nothing but mild steel with nothing but carbon, you quench it in water because you've got to bring that temperature from the above transformation down in a big hurry. The more nickel there is in that steel, the slower that rate of cooling can be. Not necessarily even oil. By the way, the order is brine is the fastest cooling, then water. Salt water is first, pure water is second, then you get into the oils and then air. Winchester actions usually have enough nickel in them that they will air harden. When you take the torch away from it, that son of a gun will make a hard place, and the surrounding metal, the surrounding cooler metal, stepping over here again, make it a Winchester with a recoil lug on it, and we've got 8 or 10 of those holes down the side of them. They look like a Precisi board. And you're going to try to take out as much as you can to make the funnel that we talked about so you can go all the way through. But this metal out here, you're trying to keep cool because you don't want to have to reheat treat the whole thing. You're trying to keep it cool. Well, that cool metal makes a bullseye where it hardens. And you get those little bright rings around the welded up holes. They're just miserable. Sometimes you can get them out of there with a torch. You can actually just wave a torch around and around just to kind of a dark blue, not quite a red, 850 degrees or so, and kind of try to blend that stuff in. But then you got to worry up here, you've got a lock and lug recesses, you don't want to get too hot. It's a tough problem. If you can plug them, it's best to plug them. But in order to plug them, you've got to have another receiver. Then you got to cut plugs out of that receiver. And it is a problem. It really is. I wish there was an easy solution. I tell people, I said, I'll weld them up. I sure will. And I'll do the very best I possibly can, and I'll use every trick I can and maybe even experiment a little. But I can't guarantee there won't be a bullseye. Yes?
One thing we might consider, I've welded up, these are just trigger guard tanks and such, and I've got a little furnace, I do some charcoal blacking.
Yeah.
And in charcoal blacking, you're packing your part in charcoal and you're running a temperature about 750.
Right.
And I get fabulous, really nice blacking, and there's no sign of weld. Doug Turnbull may end up have himself a gold mine, because I would consider, these original 364s were machine blue, which is charcoal blacking, which
Yeah.
is 750 degrees. And I'd be willing to bet you guys that if you charcoal black one of those puppies, you wouldn't have anything, it'd clean it right up.
Pete Mazur's come up with a good point there. Charcoal blacking instead of rust blue or hot dip blue, whatever, you may be able to get away from these things. That sounds a whole lot like an unpaid announcement that he's doing charcoal bluing, is that right? Okay. Yeah. That is a good idea. Charcoal blacking occurs at about 750 degrees or so, and it's a heat blue instead of oxidation or rust or whatever. Good idea. But they are miserable. They are hard to do. They really are. I have done some pretty good welding on early 94s. If they're made before 1905, they're generally case hardened. You can anneal, just kind of spot anneal in a place or two. Good tip for spot annealing, just take a cube of steel. I use the butt off the tally bolt knobs. They're 7/8 of an inch in diameter and about 3/4 of an inch long. Heat it up red hot, sit it where you want to soften. Just sit it on there, let it cool, and it will anneal the place underneath. For Springfield receivers, for drill and tap, that is really handy. It just anneals a stripe right across the top, right where they're sitting. Just heat them up cherry red, set them on there, let it cool, very cool. Any questions about that? Winchesters are tough. I was asked to cover silver soldering. In all joining of any metals, cleanliness is the #1 thing. In TIG welding, you don't want any carbon, you don't want any oxygen, don't want any sulfur, silicon, manganese. The list is long. In soldering, it's the same thing. I silver solder bandsaw blades together and have for 25 years. Just bevel the edges, made a little fixture out of a piece of angle iron. It may be worthwhile to draw this. Just a little piece of light angle iron. And I went in with the, yeah. I'm not very good at the 3D stuff, but a piece of angle iron, and I just ran the milling machine over it to cut a step in it to locate the back of the bandsaw blade, and then cut a notch out of it. I hold that in the vice jaws, put the bandsaw blade right across here with a clamp on both sides, and overlap the ends. Put a drop of silver solder on top, weigh the torch on the bottom, it sucks it right through. All kind of solders. The solder follows the flame. You can draw the solder toward you, it will come to the flame. It will come to the heat source every time. So in silver soldering, I was asked about secondary recoil lugs. I kind of like silver soldering secondary recoil lugs. It is stronger. I still put pins in them. But if you got a heavy kicker, I call them snot slingers, and you want a secondary recoil lug up here to soak up a little bit of that extra energy in the forearm of the rifle, I put a couple of locator pins in there, and I clean that steel by draw filing. I put the block on there, I scribe around it, I take the block off, and I draw file inside and leave it a draw file finish. Same thing with the block itself. I flux both sides. And I'm going to make some recommendations on material here in a minute. I flux both sides and lay a piece of ribbon solder in there that has been cleaned mechanically. I generally use a piece of wet or dry, rough wet or dry. Just take the ribbon, strip it between the wet or dry, make it good and bright. Don't touch it. Cut it off with scissors, use your tweezers, sit it in there, try to get it all together. Use a spring clamp to hold the parts together. If you use a mechanical clamp, when the silver solder melts, it reduces the amount of gap you've got there, and the clamp is loose all of a sudden. If you use a spring clamp, when the silver solder melts, it'll go together. Temperature is the most important part. Just a dull red on silver solder, 1110, 1115 degrees, somewhere in that area. And both sides have to be the same temperature. So start heating the barrel way back in here, way on out here. You want a good even temperature range. Heat the barrel first because it's heavier. It's going to take more heat to work with it. Then start on the block. More barrel, more block. When it gets to the right temperature, you'll see that flux come out of there, and it looks like glass, it looks like water that'll flow out of the joint. Wave the torch tip along that joint, and it'll suck that, it'll draw that silver solder right out the edges. Pete?
I can't stress enough that concept of the solder flowing to the viscosity of flame. When you're trying to do soft solder barrels together, you know, on double gun,
Yeah.
you've got that real long solder joint.
Right.
I know Jack Jenkins, who I apprenticed to, one of the things that he showed me was, for example, soft solder, you know, something together. All you do is you run your solder on one side, your flame on the other. You just see the solder coming right up.
Yeah. That solder just runs right to the flame. Braze does the same thing. When you're brazing on a big piece of stuff, do the same thing. Yeah. Yeah. If you don't see the solder come out, you know you got a void in there. Then when you rust blue something, you got a real problem, because the solution will get into that void, and then you got a problem. Any questions on that?
This doesn't hurt barrels to get them. That always bothered me. It's okay.
No, yeah, just fine.
Wakes me up overnight.
No, barrels are not too bad. Now, TIG welding on barrels, that's problematic. I thought one time, just when Ruger came out with the Lord's Prayer, you know, the do not use this gun unless you're a human and two-legged and got a brain and all that kind of stuff, and it's all kind of disclaimers. I was like, that'll be easy enough. Just weld that dude right up. Got an oblong bore. Doesn't work. Anytime you weld, this is something, just for instance here, we're going to put together two pieces of plate, and you got a big wide groove there called a J groove, like we said. When you weld this, those plates are going to wind up that way. It will bend toward the puddle. There's a way around that. You can peen it. It actually stress relieves the puddle. So if you weld two plates, build up some extra weld there and get on it with a 4-ounce ball peen right away and just tap the daylights out of it. All of a sudden that summer's going to go relaxing. It'll straighten back out. Gary?
My father was a certified boiler welder,
Ah,
and he worked as a saw filer for a long time, and he'd take these great big huge bandsaws and weld them together.
yeah,
And I happened to be in the shop one time, and he showed me how he did them on a great big old iron table, like, you know, with rollers on it.
Yeah.
Bring this thing together, and he welds this thing with gas.
yeah,
You know, back in those days, they didn't have TIG. And there'd be a big puddle like that right there. He says, now watch this. And he'd heat it up with a big red torch.
Yeah,
Get it
rosebud.
red on both sides of the weld.
yep,
And he'd start pinging that with a ping hammer
yeah,
all the way around. And you get that yellow splash.
yeah.
And he says, and it stops right where the weld is.
Mm-hmm.
But he keeps pinging it until that yellow splash goes clear through. He says, now it's one piece.
Interesting tip.
All the molecules are in the same direction.
Yeah. I just wish we could go back and recover all of the tricks and tips.
You can imagine how strong that weld has to be on something.
Oh, yeah,
They really like that out of hell. There's a lot of damn pressure on
yeah. I always thought it'd be real neat to TIG weld bandsaw blades together, and I found silver solder was a whole lot better.
Yeah, you could use the sheet silver solder on the bandsaw blades too.
Yeah,
Or the flame.
yeah, sure can. Bandsaws take a lot of pressure. I'd cut out knife blades and stuff with them, you know, where you steel cutting in stainless. There's a lot of pressure on them, and I broke them. Sure, I broke a couple. Not many at all. I used to work for an outfit. This is a form of a disclaimer. I worked for an outfit called Rock Mount Research and Alloys out of Vancouver, Washington. And they did essentially the same as what UTechTech does. It's a specialty welding house is what it is. They started out in the space program making different kind of wires, different alloy wires for space applications, the space program, and then they got into the welding alloys. It's called Nassau Rock Mount, actually. Rock Mount is West Mississippi, Nassau Rock Mount is east of Mississippi. Their 800 number is 800 ARC Rods, ARCRODS, Vancouver, Washington. They make alloys. Just call them and ask for a catalog. It's well worth it to have a catalog. They have arc rod, TIG rod, and solders, all kind of coated brazing rod, silver solder, all kind of stuff. They have high-speed steel in TIG rod, MIG wire, and arc rod. If you got a special tool to make it out of cold roll, TIG on a little bit of M2 high-speed steel, grind it back. It's not going to last like a end mill will, but it'll last long enough for that one job. They have a TIG rod that I've been using now for about 15 years, and it's called Tartan, T-A-R-T-A-N, Tartan TIG. I understand that they now have a bigger minimum order, and I'm thinking real serious about maybe stocking some of it for the trade, because this is great stuff. It works just as well with oxyacetylene as it does TIG. It is a copper flashed rod. It doesn't rust. The real handy thing is that you can order the stuff with a tag on the end of it that tells you what it is. Got a little tag. Bob Snap.
Jack gave me some of this a few years ago. Oh, you gave it. Jack gave it to him, he gave it to me. We gotta keep this guy straight. Anyway, I use oxyacetylene, and I'm welding a great big chunk iron on these Martini Cadets to make a pistol grip. And I ran out, and this is great stuff. I just run it in there and weld it, and it's beautiful. Never get any bits, beautiful. And ran out of it here earlier this year, and got some rods locally, and I spent about 12 hours welding up pits on that. Get this stuff.
Tartan TIG is called a triple deoxidizing rod, and I don't know how they do that, and I'm not real sure what it means. But it's extra guarded against oxygen, I guess. Now, Steve Heilman tried some, and he likes his Lincoln better, and I don't know the number of that. He uses a Lincoln rod, and you sure can't argue with his results. Certainly not. So there's evidently several different things around. Rockmount makes every kind of alloy you can imagine. If you got a buzz box and you want to weld aluminum, they got a rod that'll do that.
You write the name down again, Jack. I've been 3 years trying to find out about this. Write the name of the company down.
Oh, yeah.
Phone number.
I can even tell you the gal that mans the phones.
Wouldn't that be woman's supposed?
Yeah, I guess. It's a good outfit, and boy, they do a lot of really good stuff. I guess that's right. I can never remember the numbers that go with this, but I know this equates to most telephones. You want to talk to Mary Ann Bell, but we always call her Ma Bell. Ask for a catalog, and they make a silver solder called Gemini G. I buy it in 16th inch rod form that it's flux coated. It's got a bright yellow flux on it. I use it for everything, even on the jobs that take ribbon solder normally. What I do now is take like the secondary barrel block, and I will actually just run a little bead of silver solder, just splash some silver solder down on that barrel block, put the barrel block, the secondary recoil block on the barrel, and then go at it just like I would with a ribbon. It is so good, and the flux is so aggressive that it really works. Yeah. Gemini. Rockmount uses some codes that maybe I can tell you. If it ends in A, it's an arc rod. If it ends in G, you use gas. If it's T, it's TIG, and if it's M, it's MIG. A word about MIG wire. When I worked for that outfit, they gave me a briefcase full of samples, and I'm still using off of it. Of course, I reordered samples every so often because I did demonstrate a lot of rod. I got a little sample spool. There's 2 pounds of tartan MIG, 032 diameter, real fine stuff, also copper flashed. I just decided I'd try it. Works like a champ. If you've got one letter that you need to TIG up, I know nobody in here would falsify anything whatsoever, but used to it was fairly common to take a stainless 357 Ruger, rechamber it to 41 or 44 if you really want to get wild, even 45, have the barrel rebored, and you just weld up the 357 and recut to 41 or whatever you wanted. Just drive those collectors crazy. But you can actually weld up individual letters. For the real fine wire, 032, I use an 032 tip, a TIG tip, and you'll need an extra collet.
Silver solder, silver braze.
I call it silver solder, but the proper term is silver braze. Yeah.
What's the name of that one you like?
Gemini, Gemini G.
And it has the flux on the rod jack?
It does have the flux on the rod. I have an extra jar of Gemini flux. That's good stuff. Yes.
Does that also come in a ribbon?
No, I don't think so. Now, it's been 12 years since I worked for them, but I don't know that they have a ribbon. Most everything they have is flux-coated rod. They've got a brazing rod. It's 130,000 PSI tensile. Used to demonstrate that stuff. I'd ask a customer if he had a grade 8 bolt and a nut. Put the bolt in the vise with the head sticking up, stand the nut on top of that, and braze it on there. Hand him his own 5-pound hammer and say, now if you can take it off there, I'll give you a pound. I never lost a pound of rod. Never. They weld together bicycle frames with this stuff.
What's the temperature there?
The Gemini is 1100, I think, 1110, somewhere right in that area. It's great stuff. But they have some real specialty rod. They've even got phosphor copper for sliding surfaces, for sliding bearings, and arc rod. Lay that stuff down. It's just neat. Any questions? We got about 10 minutes here. We might as well turn it into a bull session. Yes?
I got a question. Going back to that silver soldering on the barrel,
Yeah.
are you getting any kind of discoloration over the chamber area? How close are you running heat to that?
You'll get a light straw somewhere in there. Just understand that a good barrel, anyhow, has been thoroughly stress relieved. It's already been to 1,000 degrees and then cools slow. So it's really not going to hurt them. And if you start taking, what's that?
The lug, the accessory lug is about 6 inches forward.
Yeah, yeah. But it's not going to hurt anything if you heat it up. You don't want to quench it. I've got a piece of a thermal blanket, one of the old pre-asbestos band blankets that the welders use. And when I'm doing a barrel, I'll just drape that blanket over it just to hold the heat in there longer, let it cool slower. That's much better. You don't want to stand it out in the yard, sub-freezing temperature.
Do you use anything to protect the bore surface from oxidation or scale?
You can. I generally just clean them real well. Take all of the oil, everything out of them, run a couple of dry patches down them, and don't worry about it. It won't heat up enough to scale. It takes a good bit more than that to scale them. The scale will come up at the temperature of transformation, which is about 1700. You're all right there. Yes, Dave.
Jack, on that blanket, if you know anyone that works in the drop forging or area, they use that blanket to equalize the dyes all the time. They don't use it very long. When they chuck it, it's still good for most of our lifetime.
If you're up there in the Rust Belt where they do drop forging, Dave says, Dave says they use these thermal blankets to even out the heats of the dyes, and you can use them. But any welding shop has them. Any welding shop. Preheating. If you've got something that is really, really tough to weld, you're really having trouble with it, it wants to warp, it wants to pit, it wants to do all kind of stuff, preheat it. Kind of spit sizzle hot. 350, 400, somewhere in there. I do it with an oxyacetylene torch. Wave it along there until a wet finger really sizzles. Then TIG weld it. You'll be amazed at how much better it welds when you're welding hot metal. It's a good thing really to preheat all of them. Anything else? Gas?
I mentioned a while ago, Jack, about cutting or welding on an action, getting back in and welding the rails, welding
Yeah.
inside. Do you apparently, when you put an action together, do you butt them together? You don't have any room because you're worried about the contraction when they cool? What's your...
Let's cover action shortening just a minute. It's one of the most interesting jobs you'll ever tackle and one of the toughest. Everybody got this stuff? Anybody that shortens actions will have a big box full of failures somewhere. I started out with a square piece of just steel. I don't know what it was, but it's 2 inches, probably 2 inches square, about that long. I surfaced the top of it off. I cut a notch all the way through it, right where the ends of the action is going to come together. Mill out actually you need 2 places, one for the boss on the rear tang and one for the sear hanging down on the back end of the action. And then I milled out a notch right here with a hole, so the front lug, the front recoil lug, I do nothing but Mausers, try not to. The front recoil lug goes in here. It's held in by a 1/4-22 screw. The same back here, it's held down, and then in the middle through the sear opening, I put a screw down through that with a piece of round stock that fits the roundness of the bottom of the action, where the bolt raceway is on the rear tang. The bolt runs through that, through the sear hole. So both sides of the rear is held down in 2 places. The front is held down here. Then I have a square block that fits inside the feed rails, and a screw goes through that. So the front is held down in 2 places also. So the whole action is indexed off the bottom flat. And where they butt together will be over this open area right here. Now Ted just brought up something very good. I'm going to have to try this. I love these shows because we can always steal information. Oxygen-free, OFHC copper. Something oxygen-free, something other copper. Hydrogenated or something. Well, that sounds like something you put French fries in. But anyhow, he brought up this copper, and this is an old welder's trick. Take a copper plate with a dimple in it and just run a end mill through there, whatever you want to. And when you're butting together something, it'll be over this divot. So your steel comes in that way. You weld from the top only and allow the metal to drop through the bottom. Allow it to drop through, it won't stick to the copper. Don't worry about it. He's talking about doing the same thing in the inside rail. Now that's a good idea. The one thing you don't want to do, and believe me, this will fill your box up faster than anything else, is think you're going to string an action on a mandrel and weld it together. If you string that action on a mandrel and weld it together, you're going to have one part made out of three, because that mandrel is not going to come out. It's going to warp just enough that you can sit there and beat on that son of a gun all you want to, and all you do is put a mushroom end on it. Always weld them to a plate. Don't try to put a mandrel through them. And there's a real secret in straightening them back out, because they're always going to be a little bit crooked. They're going to, even on a rear bridge, when you put on a rear square bridge, it's going to warp out of shape a little bit. The bolt won't go back in. I've forgotten now what the decimal equivalent. It's 43/64, I believe it is 703 decimal. I think that's right. You can buy carbide tip reamers, fairly inexpensive. And is it 43/64, 45/64, so I forgot now which it is, but decimal equivalent is 703, which happens to be what the opening of a Mauser is, and most bolt actions. So what you do, once you get this thing welded, make a bushing to fit the front threads that fits the shank of the reamer. You got to put the reamer through the bushing, then put the bushing into action. But what that does is align the reamer with the front receiver ring. Then you can run back here with the reamer and take out that rear ring to straighten it. And it's so much easier than a chainsaw file you can't believe. And I guarantee you, if you try to straighten out that rear ring from the back with a round file or stones or whatever, you'll get it where the bolt will go in, then it won't go in the front one. So line everything up with the front and then go to the back, and that works.
What do you use to keep the receiver and just fold it all down? How do you keep that straight after you cut it? Do you lay it against the groove or something against the side, or just by?
No, just a 6-inch scale. The question was, when you cut the action in half, looking at it from the front here, how are you going to keep the two halves together this way, lined up? I just lay a 6-inch sterret right down the side rail, butt them right up. They're always going to warp, Ted.
Yeah, put a mandrel in it while you're hooking it to the block.
Yeah.
And then pull it out before you weld it up.
Yeah, you can do that, but I'll attach mine from the inside so I can't use a mandrel. They're a complicated job. Anybody else?
Okay,
Bob.
once I had to weld on a barrel. You don't weld on barrels. Once I weld on the barrels, and I think I got part of this from Ted. If you weld on a barrel for running water through it.
You can work, yeah, you can.
Well, I did. And the barrel's not sitting level, it's sitting uphill, and you run the water in from the downside so that the barrel is full of water at all
Yeah,
times. And then
bumping it through.
Come out the other end onto the floor or the bucket.
And you don't want anybody to come into the shop about time that water boils and shoots a line of steam out of there at about 900 miles an hour.
Never got it that hot, and then boiled the water, because you run the water through from a hose, so there's new water coming out.
Yeah.
But, and you weld kind of quick, like, you don't sit there for a half hour and weld it.
I have welded pits. I have TIG welded pits in valuable barrels, ones that you really don't want to have to trash.
That's what I was doing.
And I grind them out, and I preheat the barrel till it's, just about too close to be around, and then just TIG very fast, and you can get away with it. But sometime, if you run a lap through there, you'll feel just a little bit of a hitch. You'll have to lap it. Yes.
Jack, remember Alabama when I say this, but I've also been told that you can solder a gas tank. If you run the exhaust pipe inside the gas tank, you can solder a gas tank, but I've never tried it either. So there's a lot of things that I've been told.
Don't want to try it.
Yeah.
The guys that tried that and it didn't work, we don't hear from. Have you ever wondered, you've heard the stories of the World War II flyers that was pushed ashore by the porpoise? Well, how about the ones that got pushed another way? We never hear from them. Yes.
In relation to your question, when I first started teaching, there was a gas tank in the 3 wires that came into the school shop. We tried it. The shop teacher was out of the classroom, put the exhaust in there from the engine running the
Yeah.
And it blew and that tank was wound up in wires.
Yeah, I had one pop about shoulder high one time, and I was way out of sight by the time it hit the ground. Yeah.
Washed it completely out, soap and water, the whole works. Got
And
that
it's
thing
still-
almost welded together, and that sucker split.
Yeah. People that say that steel is not porous just hadn't been around it enough. Because it captures things in little nooks and crannies and pores that'll come out and bite you. It sure enough will.
I would loan my torch to anybody that wanted to try it.
Dave.
My dad was kind of a Bob when he years ago. The only one I ever saw weld a gas tank in a toilet, he used to boil beans, coal beans, for feeding his pigs. He'd put those gas tanks on the top of that coal bean for 3 or 4 days.
Yeah.
And then he welded and he never blew.
The biggest welding rod sales that I ever had was here in Nevada, is over at Lovelock. There's a bentonite plant over there where they process clay, what it amounts to, and the whole thing is fired by fuel oil, diesel fuel. And they had a 6,000-gallon fuel oil tank that had leaks. I mean, it was leaking like a sieve. They had to build a berm around it to catch the stuff. And I was in there demonstrating welding rod, and Rockmount had a stuff called Polaris. It's 100,000 PSI, and you can store it in a tank of the toilet. I used to do that as a demonstration. Here, take these 2 rods, we'll put them in the back of the toilet. Next time I'm here, we'll run them. It'd run underwater, it'd run when it's wet, it'd run anything. And this guy said, we've got to fix this tank. It's going to take about 600 pounds of welding rod. Will your rod run through diesel fuel? Oh, yeah, hell yeah, it'll do that. He said, if you show me it will, I'll buy it. This stuff is $12 a pound, 30% commission. Sitting there and I said, what's a worst case scenario here? Yeah, I'm not going to have to worry about making that money. But I made sure that there was a good clearance, you know, about 3 miles in every direction that I could run. We hooked that dude up, and that stuff would run through fuel oil. It sure would, leaking right out of the tank, and I ran beads right through it. I only did about 2 of them. There you go, I told you. And I made the sale. It was a big one, my biggest. I enjoyed it, folks. Ah, thank you. How about that? Yeah. Add that to the deck, huh?
Thanks a lot.
You're welcome.